So for lockable energy sources, electricity, air, which is compressed gases, chemicals, sometimes chemicals are lockable, fuels, if they're coming into the machine, steam, water utilities. Anybody think of any other lockable energy sources? That's quite a few of them. There's also sometimes hydraulics are lockable if it's a separate hydraulic pump that powers multiple pieces of machinery, like we were looking at for your facility. You have remote hydraulic pumps. But in general, any energy coming into the machinery that can be blocked or locked is a lockable energy source. The non-lockables are what we'll talk about second. So what dangers are associated with electricity? Obviously an example of what not to do as an extreme. Medium voltage, 110 to 220 volt, can cause shock, cardiac defibrillation, sparking, fires. Higher voltage, 440, burning of internal organs. Both can cause death, though, very easily. And sometimes the lower voltages are more dangerous. Anybody know why? Got an electrician in the back.
Amperage.
Amperage, yeah. Volts shock, current kills. Why would a lower voltage be more dangerous, though, than a higher voltage in some cases? Like, why would 120 be more dangerous than 480?
120 is more common, 480 volts.
Well, yeah, you're exposed to it more. Sometimes there's problems with letting go at lower voltages. Higher voltages will blast you off and you'll have burns and some shock. Lower voltages, you can't let go. It interferes with your bioelectricity in your body, and your muscles are electrical. You can't let go once the shock starts. So how to verify electricity is not present? Use no-touch voltmeter or a voltmeter, multimeter. Make sure the multimeter is rated for what you're working on. I've heard stories of people using a 500-volt multimeter in a 4160 cabinet. You've just completed the circuit, essentially. It's going to turn it into a bomb in front of you. It kind of sounds funny, but it's not. People have died that way. It catches them on fire and blows them out of the cabinet. You've essentially created an arc flash situation. Short-circuited it. So how many amps? You'd mentioned amps in the back. How many amps does it take to kill a person?
.1.
All right. Everybody benefited from him yelling it out right away. A lot of people think it might be a higher higher amperage, but it only requires 0.1 amps, and sometimes that's more dangerous. Just again, it communicates with the bioelectricity when they use cardiac defibrillators. 0.1 amps. That's how you're going to get your heart restarted. 20 amps, 3 amps, those are the ones that don't interfere as much. They go in and out of your body, you have the burns, but you don't have the problems with the heart rhythm resetting, things like that. The purpose of telling you this is so you know, just because energy is small doesn't mean it's irrelevant. Just because energy is small doesn't mean it's not more dangerous. So air, how's air dangerous? Pneumatic compressed gas.
Pressure.
Yeah, pressure vessels. It can cause moving parts like we saw in pneumatic cylinders. There's a lot of pneumatic cylinders in manufacturing environments, right? Not locking out air can cause movement of the machinery, or it can cause a release from a vessel. Saying that again. How do you verify it's bled off? Check the gauges, right? But do you trust just a gauge? No. There should be an emphatic no there, because gauges so often fail. It might be a false sense of security. It might be broken and bent to 0 when really it's at 60 psi. So you want to check gauges, but don't use that as your only source. Also move levers, verify the machine's not, and when you're working on it, when you're actually, think you're at 0 energy state, you've checked your gauge, you've moved the levers, when you're operating on it, keeping in mind that there's no physical way to see that the air is bled off until you're breaking into the machine. If you hear hisses and you start to see indications of there's still air pressure, back away and reassess the whole situation. Fuels and chemicals. Dangers associated with fuels and chemicals. Sometimes they can be locked out, sometimes they can't. They can cause chemical burns, eye skin irritation. They also can mix acids and bases, can cause explosive high heat or high toxic oxygen deficient conditions. So remembering, chemicals aren't the only hazard. Sometimes it's the mixture of chemicals, sometimes it's the influence of chemicals on your body that pose the hazard. How to safely control, monitor, and neutralize. Make sure you understand what chemicals you're working around. What's MSDS? right? It'll tell you what you're working around, how flammable it is, what hazards it are, what the reactivity is. Make sure you have proper ventilation if you're working in a confined space. Make sure you have the ventilation if there's chemicals involved. Use a LEL meter or a 4 or 5 gas meter. What's LEL? Anybody know? Lower explosive limit. It tells you at what point, if there's a spark, the air could ignite. You want to know that if you're working in that environment.